Hi everyone, this is a lesson about how we might use technology, in particular Microsoft Excel, to answer a question like this. So we have a group of 17-year-olds, and to the nearest centimetre the heights have been measured. Here's a nice little table with 20 entries. We're to construct a probability histogram for the heights with a class width of 2. So the first thing that I will do, I've copied my data array here, and the first thing that I want to think about is the smallest number in the array. Now, of course, you don't have to use technology to do this, but it is a lot more convenient. So we might as well do a technology-based solution. Let's also find the maximum value in the array. There we go. Now, that will give me a bit of an idea about the, well, they told us we needed a width of 2 for our, let me just put that in the center, a width of 2, and our lower limit. Well, we're going to have a number less than 158. And because this is a continuous variable, the height, say, of 158 that was measured, there it is there, that might have actually been anywhere from 157.5 up to 158.5. Anywhere within that continuous range would be recorded as 158 because it says where they were measured to the nearest centimetre. So to reflect that, I'm going to put a lower limit of 157.5. Now, with my width of 2, anything from 157.5 to 159.5 would get counted in the first, we call them bins. So here's my height. Well, this is going to be my table. My height, I'm going to start with the lower limit that I've just assigned. Then, well, what would the next one start with? It would be the previous one plus the width. I'll put absolute references there on the width, and then if I copy those down, now I should go far enough that I would exceed 181. So I might have gone one too far there. Now let's do the upper limit of each. Well, it would be the lower limit of each bin plus the width. So I'll put dollar signs again on the width, and we'll copy them down. Now let's see what we've got. The greatest value of 181 would in fact be in this bin here. So we've gone a bit too far. Those ones aren't needed. When it comes to finding the frequency, we could go through there one by one and count them up. Very tedious, very inaccurate. Excel has a function for this. Not surprisingly, it's called frequency. Whoops, I've gone wrong already. The first thing I need to do is highlight the entire block of cells, an array, where I want this to happen. Now I'll type my frequency formula. It says where is the data array. The data array are these, so I'll highlight them. Now where is the bins array? I've got to be a bit careful. With Excel, it wants the upper limit of each bin. So what it will do is it will search through this blue array and find every value which is lower than 159.5 and count them and put them in this cell. For the next one, every number between 159 and 0.5 and 161.5. So I'll close the bracket. Now for an array formula, remember, press Control and Shift, then the Enter key, and it writes the formula all the way down. There it is. There's the formula. These are my frequencies. I might just put them in the center of the column. The relative frequency would represent the probability of an outcome being in any particular bin. So I'll calculate that. There's 2 outcomes in that bin. Now what do I need to do? I need to divide by the sum of all of those. Again, dollar signs to make sure that I don't mess up when I copy. And that's going to give me 0.1. In other words, there are 20 of these in total. 2 out of 20 is 0.1. There is a 0.1% chance. That's lovely. Now with a histogram, we want to make sure that this relative frequency represents the area under the histogram block. The histogram block will have a width of 2. So if I used that as the height, I would actually end up with 2 times that, or double the area. The column height should be the relative frequency divided by the width. And again, absolute reference on the width. My column height should be 0.05. Let's copy them down. And now I'm just about ready to draw my histogram. I might just move that off to the side, out of the way, to give, oh, go on, over there, to give myself a bit of space here. So let's make a histogram. Now, Excel has a few funny little things. So you highlight the vertical axis values, insert, and it's not actually called a histogram in Excel, they call it a bar chart. There it is. What's a suitable title? These were 17-year-olds, weren't they? That's good. Now, we notice that these are not a very good histogram because these things are very narrow little bars. So if I click on the data series and then go to Format, I can come over here to Format. I get to choose the gap width. I don't want any gap width. There we go. So they're nice. They look nicer now. I'd also like to have an outline around those. Let's have a black outline around those so it looks like they're distinct. I need axis titles. Here we go. So my vertical axis title, that is the probability. And the horizontal axis title, this was the height measured in centimetres. There it is. Now the only other thing that's a bit annoying is that Excel just automatically numbers these 1 to 10, 1 to 12 sequentially. And I don't really want that. I want these numbers across the bottom to represent. Now notice also when we do a bar chart, Excel puts these numbers in the middle of each of these blocks. So I really want a label here which is midway between each of these. That's why I left a column here. So I will calculate the midpoint of each of these. Let's just copy those. And then by clicking again on the chart, I come up here, this time to the design and select data. It's buried down here in the menus, but this first data series, the blue blocks, I can edit the axis labels. I can make I can say Excel, go and use these numbers as axis labels. And there they are. They represent the midpoints. And I might just turn those sideways because I think it makes it look a little bit more obvious that those represent the midpoints of each of those blocks. Now, what does this mean? Well, this is a continuous probability distribution, and the area of each of these blocks represents the probability of an outcome in this range from 157.5 to 159.5. The area of that block is 0.1. If you multiply the height by the width is 2, you get the probability. Of course, the sum of all of these has to equal 1 because something has to happen. You have to have an outcome somewhere. And that's the first question. We have constructed the probability histogram with heights and a class width of 2. What about constructing the histogram with a class width of 10? Now, if you were doing this on pencil and paper, you would have to start all over again. But through the power of the computer, I can literally type 10 there, and it does it all for me. There it is. It's calculated everything. It's recalculated these width, the lower and upper limits of each of these classes. It's done the frequency by comparing to there. It's done the relative frequency, the heights, and redone the labels, and there it's redrawn everything for us. Now, please note that your histogram may look different if you choose a different starting point. 157.5 might not be considered a sensible starting point if you have a width of 10. If you have a width of 10, you might want to jump up, say, imagine the values from 150 up to 160, so we'd go 149.5 with a width of 10. There's a histogram, and the midpoints of these are now closer to the midpoint of each decade. almost the middle of the 150s, the 160s and so on. So the starting point as well as the width of the histogram will have an outcome on the picture that you end up drawing. I think that's enough for now. That's a long enough video. And again, if you calculated for part C the area of each of those blocks and added them up, they would still need to come to 1. Have a go at making one of these for yourselves if you want to, and you could use that to solve the exercises in your class, rather than a lot of wasted time counting numbers. Thanks for watching.